Hello everyone. In this video, we are gonna practice factorizing, but specifically, we are gonna learn how to factorize certain expressions that we learned in the last video, like difference of two squares and perfect squares. There are some examples that on the screen right now that you can see of difference of two squares. Yeah, let's see how it goes. Before we go any further, I wanna briefly organize what we learned last time. So the first one was a squared minus b squared equals a plus b times a minus b. And the second one was a squared plus b squared plus 2ab equals a plus b squared. If you see minus 2ab, then you get a minus b squared. So yeah, these were the formulas. So like we are gonna factorize in like very specific forms, and probably in the next video we are gonna learn like how to factorize a little bit more generalized form, like things like this: x squared plus 2x plus minus 3. Yeah, like how to factorize these kind of quadratic expressions. But for now, we are gonna focus on those 3 formulas. So and then also we proved why those formulas were the case by just expanding brackets. It's like super easy to expand brackets. You can just do it one by one and then like multiply, and then like combine them together. So yeah, it was pretty straightforward. For now, we are gonna have a look at some examples of difference of two squares. So this one is x squared minus 49. And then if you keep in mind 49 equals 7 squared. It should be really straightforward. If not, then you will get better by practicing a little bit more, like many questions. I think it's important to see many questions and then solve as many questions as you can. So we could change this expression into like x squared minus 7 squared. Why though? Like it's pretty obvious, like those two are the same, but like the reason that I just changed this form is to see the formula. I'm gonna write down just one more time. Yeah, if you see the difference of two squared, like something squared minus something squared, that means you can just express the expression in a different way. So in this case, x squared minus 7 squared, then you can factorize this expression like x plus 7, you like combine them, and then one thing is like the difference, right? The difference. So like x plus 7 and x minus 7. So this is how to factorize, the difference of two squares. And then next one, a squared minus 4. So like the first thing that you should do is recognize that 4 is 2 squared. You don't really have to write that down, like 4 equals 2 squared. Like if you know, like, and then if you can do like without actually going through all this process, then it will be ideal. So like it's a squared minus 2 squared, like to see the formula like hidden inside this expression. And then you just change this into a plus 2 and a minus 2. So like one is plus and one is minus. Like that's what we learned last time. This formula. We just use like those formulas and and then we call them factorizing. Another thing is now it's not a number. Like they both are variables. Like in this case m and n. But I don't know, like for me it looks like way easier than before. So like we know like one is m and one is n, like we kind of just square them both, and then it's kind of the difference of them. So like it's just m plus n, m minus n. Just just a quick tip. If you wanna check, like, let's say you are not really sure. Now I'm pretty sure like this is right, but when you are not sure, like if you did the factorization and then, oh, okay, I think this is the answer, but like, I don't know, it could be an exam and you have a little bit more time, then you can expand it. You can expand this and see if you can this original expression. You can just expand it, one by one. M times m, so like m squared, and then m times minus n. That's how we get minus mn, and this is n here and then m here, so plus n m, and then n times negative n, I should say, and that's how we get minus n squared. So you can cancel these two, and then that's how you get m squared minus n squared. Like, yeah, this can apply to basically all the questions in factorizing. Like, factorizing means you just do expansion but in reverse. So like you can just expand the factorizing form, then you get the original expression, hopefully. Yeah, this one, yeah, could be a little bit more difficult than before. Yeah, let's see. But like the basic rule is the same. You see the difference of two squares, and then you might need some technique like to change some terms, and then makes it easy to factorize. Now 16p squared minus q squared. Actually 16 is 4 squared, so that's why you can change this 16p squared into 4p and then square like as a whole. It's different from 4p squared. This is basically, yeah, now this is this has become basic index rules. But like if you see like ab squared, then basically you just hit the power, like power hits everything inside the bracket. So like this power, in this case 2, hits all the variables in the bracket. So like that's how you get a squared b squared. If it's like 2ab and then square as a whole, then you get like 2 squared times a squared times b squared. Why? Like it's pretty much the same. When you deal with power like with brackets, then its power is just abbreviation form of just multiplications. So like it's same as 2ab times 2ab. So like 2 times 2, 4, a times a squared, b times b squared. So 4p squared, this is the same as 4 squared and p squared. So like that's how you get 16p squared. So like you can now, yeah, you can change this into like 4p squared minus q squared. And then now it's obvious, you can factorize this like 4p plus q and 4p minus q. Yeah, so like this, this a and b thing, a squared minus b squared equals a plus b and a minus b. Now a is 4p and b is q, so like 4p plus q and 4p minus q. The next one is also, yeah, difference of two squares, but in this case binomial squared minus a squared. Yeah, so let's see. X plus 5 squared minus 9, so pretty much the same. 9 equals 3 squared. So don't panic like when you come across this kind of question, because it's just a little bit different from what we have done so far. So it's pretty much the same. You can see this square here. So like inside, this is gonna be a, like as in a squared minus b squared. But we kind of put x plus 5 into this a position. So like that's how you get like x plus 5 square minus 3 square. So like now a is x plus 5 and b is 3. And you can still do that like plus 3 and minus 3. So now you can simplify a little bit further. X plus 8 and x plus 2. Yeah, pretty much the same. 6 p minus 3 and 16 is like 4 squared. So like p minus 3 plus 4 and p minus 3 minus 4. Yeah, this is it is like something, a little bit different. Again, this is, you have to take out the common factor first. So in this case, I can see like 3 is the common factors for like those terms. So if you take 3 out, then you get m squared minus 9. Then now it's pretty much the same. Now it's the same as what we have done. This m squared minus 9, that means 9 equals 3 squared. So then you just do the factorizing again, m plus 3 and m minus 3. Yeah, sometimes it's not really that obvious, taking out common factors, but when it comes to factorization, you kind of should always think about common factors, because that's the base of factorization. So in this case, it's also the same. If you take out 5, then y squared minus 16, then it's like y squared minus 4 squared, and that's how you get 5 and y plus 2 and y minus 2. Sorry, it's my bad. It should be 4. Plus 4 and minus 4. The next ones are perfect square. It's better. Okay, let's have a look. Perfect square trinomials. Trinomials mean there are 3 terms. In this case, x squared and x and constant, maybe just a number. Going forward, you're gonna come across a lot of factorization questions like this. Probably you're gonna learn like kind of other forms of factorization, like this equals to x plus 2 and x plus 1. But like for now, we are gonna learn this like in the next video. And for now, we are gonna just use this formula. Then how do we use this formula like to factorize this expression? Actually, if you put 4 into b, that basically means a plus 4 squared. So a squared stay the same, but b squared will be 16, because 16 is 4 squared. I will just write. And then 2ab will become like 2 times a times 4. So this will look like a squared plus 8a plus 16. So if you have a look at this one, then this is just x plus 4 squared. So with a little bit of practice, you will be able to see like, oh, this is the perfect square form, and I can factorize it, I can simplify it by using this formula. It's same here. The first tip would be see the constant, see the number at the end, and if it's a perfect number, then you are a little bit of you kind of now you get a little bit of conviction that this might be a perfect square. So this is 7 squared. And then see the number coefficient of this n in this case, or like x for question number 9. Then if you if you multiply this number by 2, like 7 times 2, then you get 14. So now this is n plus 7 squared. But like you don't have to focus too much on this topic right now, because probably in the future, like, we are gonna cover a lot of practice, and then examples and questions, and then you will see better, like, because like many cases, and now you can kind of distinguish and recognize certain forms. So yeah, thanks for watching.